Hi, guys, welcome back. And I'm excited to talk to you about probability lesson number 6. Today, we get to apply what we've learned about probability and we're going to make some predictions. I felt like this was such a fun lesson that I brought out the grand piano. I hope you don't mind. Now, of course, after we learn about probability, and making predictions, you'll be able to complete your assignment DD6, which is an optional assignment for you. Okay, so let's pretend like we are genies. We're going to work on our forecasting skills, and a prediction is a forecast. So we're going to be able to tell the future by using information that we already have. So we're going to use our probability knowledge and we're going to be able to apply that and forecast. So what I mean by that is example number 1. We're going to be talking about a guy named Bob, and he works at a construction company. He works on one of 3 different crews. He either is going to work on an apartment crew, a condo crew, or a house crew. The question asks, if he works 18 days a month, about how many times should he expect to be assigned to the house crew? So our first task is to find the probability of which crew he'll work on in one day. So let's just find the probability for that. And I'm going to quickly grab my pen. And you too, go ahead and grab yours and your math journal. Okay, so if I count how many crews on which he could be, that would be 3. So that's the total possible outcomes for the crews. And then let's see, out of that, he would have a 1 in 3 chance on any given day to work on that house crew. So I'm going to actually put that probability in over here. Now I'm going to set up a proportion and use that proportion to solve for the unknown information. So let's see, it says how many days do you think he would be assigned if he worked a total of 18 days? So I'm going to put 18 in the bottom part of my ratio. And then I'm putting my X in the top part. So I can now solve this proportion for X and find out how many days out of the 18 would we expect for him to work on the house crew. So when I do that, I can solve a proportion, as you remember, 2 different ways. I can either cross multiply and divide, or I can use scaling. Now this particular proportion is pretty easy, and we can all probably solve this through scaling. I can see the relationship between 3 and 18. If I multiply times 6, I'm going to get 18. So I'm going to multiply the numerator times 6, and then X would have to be 6. So we can expect that Bob would actually be assigned to the house crew 6 times out of the 18 days. All right, so there's example number 1. Okay, guys, example number 2. If we spin this spinner 9 times, what is the best prediction that it's going to land on a yellow? Well, I'm going to just find the probability of 1 spin. And I know all of you are good at that. So let's start there. We're going to find the probability of 1 thing. So when I count 1, 2, 3, 4, 5, 6, 7, 8, 9 sections on this spinner, that's 9 possible outcomes that I'm going to put in the denominator. Then I'm counting the favorable outcomes for the yellow event, and that only occurs 1 time. So only 1 out of 9 times is this spinner going to land on yellow. Now, this technically does answer our question. This says out of 9 possible spins, how many times is it going to land on yellow? So this answer is only 1. Now, if I wanted to set up a proportion, I could do that. Remember that you're going to, in all of your examples, you're going to write the proportion for one thing, and then you can always set up a ratio, set it equal to a ratio of how many total times out of X. Then you can cross multiply and divide. So in this case, X is going to equal 1. Let's work a third example. So in this example, we are putting, I'm thinking about putting all of these marbles in a bag, and I'm going to pick one marble out of that bag, look at it, and then I'm going to put that marble back into the bag. Okay, so let's find the probability of one pick out of the bag. Okay, so that'll be our first event. So let's see, there's 4 possible outcomes, so that's our denominator. And then we're talking about the purple marbles. So I'm counting 1, 2, 3 purple marbles. So if the bag has these marbles in it, and I just choose one pick out of it, I have a 3 in 4 chance of picking a purple. Now it's asking, what happens if I picked 8 different times? So in that case, if I did it 8 different times, I'm going to set that up in a proportion, and I'm putting this number 8 in my new ratio's denominator. Then I'm going to put an X in the numerator. Now I can solve this proportion 2 different ways. I can cross multiply and divide, or I can solve through scaling. This is another easy example. So I'm looking here, and I know that I can just multiply times 2. So I'm going to multiply my denominator times 2, and I can see that X is going to equal 6. So to answer this particular question, it says, what's the best prediction possible for the number of times you're going to pick a purple marble out of those 8 picks? Well, 6 is the answer. Okay, guys, I'm on example number 4. So in this particular case, it's saying that we're going to flip 2 coins. And then we're not only going to flip 2 coins, we're going to flip 2 coins 40 times. So we've got to find out a prediction for the possible number of coins that it's going to land on heads. Okay, so we've kind of got 2 parts here. I've got a compound probability, and then I've got to make a proportion and set that up to 40. So let's see. Let's first deal with flipping the coin 2 times. So I'm going to just come right over here, and I know that the probability of landing on heads for one flip is 1/2. I know that the probability of the second flip landing on heads would also be 1/2. So the probability of both of those things happening would actually be 1/4. Now that I know the probability of this thing happening, I can now set this 1/4 equal to a proportion. So I'm going to set this equal to a proportion. I'm going to put X in the numerator. And then if we did this 40 times, how many times would it happen? Okay, so now I'm going to cross multiply, or you can use scaling. I know a lot of you are using scaling. I'm just going to use cross multiplication because I haven't done it yet. So that would be 4x equals 40. And I have to apologize for how slow my little pen here goes. I don't have an Apple pen or pencil. So I'm going to divide both sides by 4, which would then give me x equals 10. All right, folks, that means to answer this question and to bring it all around, it says, what is the best prediction that flipping the coin 2 times on heads out of the 40 times, how many times would that happen? And the answer would then be 10. Okay, guys, here's our final example for the lesson. All right, so we've got these 5 orange marbles, and it says that you select a marble without looking at it, and then you put it right back into this bag. Okay, if you do that 75 times, what is the prediction for the number of times you're going to pick a marble that's not green? Okay, so let's think about this. What's the probability when you look at these 5 marbles? What's the probability that it's not green? Well, I don't know about you, but I don't see any that are green. So the probability is 5 out of 5 times. This is actually going to be not green. So 100% of the time, it's going to be, it's sure, it's certain it's going to be not green. So when it asks if you can do this 75 times, how many times is the marble going to be not green? Well, guys, that's 75 times. It's never going to be green because there's no green marbles here. So make sure that you read the question and you're understanding what it's asking for, because it is a little tricky. I know it's not too tricky for you though. Okay, I believe you're ready to do your optional assignment, which is DD6. Let me know if you need any help, and as always, let's do some math.